Hello everyone, a warm good evening to one and all, and welcome to today's webinar. So today's webinar is CNC machine alarms. Almost every operator must know. We are not going into deep, we're just stating the basic alarms. So have you ever seen a CNC machine suddenly stop working and display a warning or an alarm on the screen? So if you're new to a CNC machine, that moment can be quite scary. You might wonder, did I break the machine or is something seriously damaged? The good news is, most of the time, the answer is no. Think about your mobile phone for a moment. When the battery becomes low, it gives you a warning. When your car runs out of fuel, a light appears on the dashboard. The vehicle isn't broken, it's simply telling that something needs your attention. A CNC machine works exactly the same way. Whenever it detects something that isn't safe or isn't normal, it immediately stops and displays an alarm. It's the machine's way of saying, please check this before we continue. So in today's webinar, we are going to understand these messages in the simplest way possible. You don't need to be a service engineer or have years of experience. I'll explain all the alarms in plain everyday language. We'll look at some of the most common errors operators face, why they happen, what usually causes them, and what you should check before calling the maintenance. Remember one important thing throughout the session: alarm is not your enemy. It's actually the machine telling you to protect itself, its cutting tool, and your job, and even you. So let's begin by understanding why CNC machine shows alarms in the first place. Before we start discussing the CNC alarms, let's first understand something that every CNC operator notices. Even from across the workshops, the colored light on the top of the machine. These lights are called the stack lights or the tower lights. They are like the traffic signals of the CNC machine. Even before you walk up to the control panel, these lights give you a quick idea of what the machine is doing. Let's start with the green light. When you see a green light, it usually means everything is normal. The machine is either running a program or is ready for operation. This is the condition we always want to see. Then we have the yellow or the amber light. Think of this as a machine politely asking for an attention. It doesn't mean that there is a fault. The machine cycle may have finished, the machine may be waiting for the operator, or a small action might be required before continuing. Now comes the red light. This is the one everything notices first. A red light means the machine has stopped because it detected an unsafe condition or an error which does not allow it to continue. It could be something simple like low air pressure or an emergency button being pressed or an axis reaching its limit or anything. Some CNC machines also have a blue or white light. Depending on the manufacturer, this may indicate that the machine is powered on, connected to a network, or operating in a special mode. One important thing to remember is the stack light tells you that something has happened. The control screen tells you exactly what happened. So whenever you see a yellow or red, don't guess, walk to the control panel, read the message, and decide your next step. Now, since we understand the stack lights, let's move one step forward and understand the error messages displayed on your CNC control screen. For example, think about your smartphone for a moment. If your battery is low, it doesn't simply switch off without warning. It displays a message saying low battery. So you know what action to take. The CNC machine works in the exact same way. Whenever a machine detects something unusual, it immediately displays an error message or an alarm message on the control screen. These messages are machine's way of communicating with the operator. It is important to understand that an error message does not always mean that the machine is damaged. In many cases, the machine is actually protecting itself. For example, you are driving a car. If the engine temperature becomes too high, the dashboard displays a warning light before serious damage occurs. The warning is there to protect the engine, not to scare the driver. Similarly, CNC machines also follow same principle. As an operator, your first job is not to panic. Instead, carefully read the alarm message, and every message is a clue. It tells you where the problem is and often gives you enough information to start the troubleshooting. Always remember one simple rule: never reset an alarm without first understanding why it appeared. The machine is trying to communicate with you. Your job is to listen before taking action. Not all error messages are equally dangerous. Some protect people, some protect the machine, and some simply tells us there's a mistake in the program. So how do you identify them? Let's classify CNC alarms into three simple categories. So far, we have understood that CNC machines display error messages whenever something abnormal happens. But here is the good news. You don't have to memorize hundreds of different alarms. Instead, you only get to remember three main categories. Think of it like visiting a hospital. Before the doctor begins treatment, they first identify which department the patient belongs to: ortho, cardio, neuro, and once the category is known, finding the right treatment becomes much easier. CNC alarms work in the same way. The first category is the safety alarms. These alarms are designed to protect the operator and prevent the accidents. Examples include over travel, door open, etc. Whenever you see one of these alarms, safety always comes first. The second category is the machine alarms. These alarms protect the CNC machine itself from the problems like servo alarms, spindle alarms, air pressure, lubrication, etc. Third category is the programming errors. These occur because of the mistakes of the CNC program or a machine setup, like syntax error or a wrong tool number or missing the ending, incorrect work offset, all these things. These alarms don't usually indicate a machine failure. Instead, they tell us that something in the program or setup needs correction. So here's a simple habit I would like everyone to develop. Whenever an alarm appears, don't immediately think about solution. Instead, ask yourself one question: is it a safety error, a machine error, or a programming error? Once you have answered that question, you have already completed the first and most important steps of troubleshooting. So, let's start with the safety errors. Safety alarms are designed with one goal: to protect human life and prevent accidents. Unlike some program mistakes that may only stop the program, safety alarms demand immediate attention because they involve situations that could be dangerous if ignored. Imagine you are driving a car and suddenly someone crosses the road in front of you. Your first reaction is not to think about reaching a destination. You immediately press the brake. That's exactly how a CNC machine behaves. Whenever the machine senses a condition that could lead to the accident, collision, or unsafe movement, it immediately stops the operation. It doesn't wait for the permission from the operator because safety always comes first. One important habit every CNC operator should develop is never fight a safety error. Understand why it stopped the machine. Remember, a damaged tool can be replaced, a damaged machine can be replaced, but safety should never be compromised. In the next few slides, we'll understand each of the safety alarms one by one and learn what causes them and how to respond correctly. Let's begin with the most important safety alarm on any CNC machine, the emergency stop, also known as the E-stop. Every CNC machine has one or more large red emergency stop buttons. They are easy to identify because they are designed to stand out in the and be reached quickly during an emergency. But there is something every operator should remember. The emergency stop button is not meant for normal machine operation. It should be used only when there is an immediate danger or an immediate service or will want to shut down the machine. The emergency stops when pressed or the e-stop when pressed. The machine immediately stops all the movement. The spindle stops rotating, the axis stops moving, the CNC control displays an emergency stop alarm, and this quick action helps prevent accidents, protect the operator, and reduces the chance of serious machine damage. The emergency stop may be pressed for several reasons. For example, a tool may have broken, the workpiece may have come loose, there might be smoke inside the machine, or there is a dangerous situation someone noticed near the machine. One common mistake made by beginners is releasing the emergency button stop and immediately pressing reset or cycle start. Never do that. Always stop and ask, why was the emergency stop pressed? If you restart the machine without finding the real cause, the same problem could happen again. Now, let's move to another very common safety alarm called the hard overdrive. To understand this alarm, imagine you're driving a car again towards a concrete wall. If you continue driving, sooner or later you will hit the wall. The CNC machine also has movement limits. Every axis, whether X, Y, or Z, can only travel within a fixed mechanical range. Beyond that point, the machine simply cannot move because it has physically reached the end of its travel. To protect itself, the machine has limit switches installed in the ends of each axis. If an axis reaches one of these physical limits, the limit switch is activated and the CNC immediately stops all the movement. This is called an hard over travel alarm. Think of it like the machine telling, stop, I can't move any further. This alarm usually occurs due to incorrect machine positioning, improper manual jogging, wrong reference positions, or sometimes after maintenance work when the axes have not been referenced properly. When you see this alarm, never try to force the axis to move further. Instead, first identify which axis has reached its limit. Most CNC controls clearly display whether it is the X, Y, or Z. After confirming the cause, the axis is carefully moved away from the limit using the machine's recovery procedure or by maintenance personnel depending on the CNC control. Remember one thing, hard over travel means the machine has reached its physical limit. So the next slide, we learn about soft limit, where the machine stops before reaching the physical limit using the software protection. Soft limit over. So imagine you are driving a car towards a bridge that has height restriction. Long before you reach the bridge, you see the warning boards and telling you to stop or take another route. These signs prevent you from crashing into the bridge. Or a vehicle is equipped with a GPS. So this GPS already knows, okay, it can go only this long. After that, there is a danger. So it automatically stops. A soft limit works in a similar way. Instead of waiting until the machine reaches the physical limit, the CNC control sign creates a virtual safety boundary inside the machine's travel range. If an axis tries to move beyond this virtual boundary, the control is limited and movement is stopped and a soft limit over alarm is displayed. Here, in this case, the machine has not reached the mechanical end of the travel. The CNC software simply knows that allowing the movement would be unsafe, so it stops the axis in advance. This alarm usually appears after incorrect referencing, wrong machine coordinates, incorrect work offsets, parameter changes, or manual jogging beyond the permitted level. When this happens, don't panic. First identify which axis triggered the alarm, then check whether the machine has been properly referenced and verify the machine position and the work coordinates before trying to continue. Always remember, hard over travel is a mechanical step and soft limit over is a software step. Both protect the machine, but in their own ways. Now let's look into another very common safety alarm, the door open alarm. Modern safety CNC machines are equipped with safety doors for a very important reason, to protect the operator from rotating tools, flying chips, and coolant splashes. Imagine standing close to a machine where the spindle is rotating at 12,000 or 24,000 RPM. Tiny metal chips can fly over at very high. So what happens? So what happens? Imagine you park your car in a large parking area. Later, when you return, you don't remember where you parked. Before driving away, you first need to find your car. A CNC machine faces a similar situation every time it's powered up. When the machine starts, it doesn't automatically know the exact position of its axis. It needs to move every axis to a known reference point, also called as the home position or the machine zero. This process is also known as referencing or homing. If the z-axis has not been referenced, the CNC control system doesn't know its exact height. Since moving the spindle without knowing its position could result in a collision with the workpiece, fixture or a machine table, the control prevents further operation and displays a z-axis not referenced alarm. This is actually very intelligent safety feature. If the machines It is the machine saying, I don't know where my z-axis is, so I won't move until you tell me. Whenever you see this alarm, don't try to force the machine into operation. Instead, perform the machine's reference return procedure according to the manufacturer's instructions. Once the z-axis reaches its home position, our control knows its exact location and normal operations can continue. Now we go to the machine errors. After the safety errors, we go to the machine errors. So what are the machine errors? As the name suggests, these alarms are designed to protect the CNC machine itself. Think about your car for a moment. Suppose the engine oil level becomes too low or the engine starts overheating. Your car doesn't continue driving normally, instead displays a warning because continuing to drive could seriously damage the engine. A CNC machine behaves in exactly the same way. Inside every CNC machine are expensive components. So spindle, servo motors, tool changer, lubrication system, coolant system, and pneumatic system. These components work together continuously while machining. If the CNC control detects that one of these systems isn't operating correctly, it immediately stops the machine and displays an alarm. This is not a sign that the machine has failed, it is the machine protecting itself from a much bigger problem. Ignoring the machine alarm and repeatedly pressing the reset button can sometimes turn a small issue into extensive repair. Whenever you see a machine alarm, don't panic and don't guess. Read the alarm message carefully, identify which component is involved, and perform the basic checks recommended by your machine manufacturer. If the problem cannot be identified or corrected safely, report it to your supervisor or maintenance team, and remember the simple rule. Machine alarms protect the machine today, so it can continue producing parts tomorrow. In the next few slides, we are looking into some of the most common machine alarms that every CNC operator should recognize. Let's begin with one of the most common machine alarms you will encounter, the servo alarm. To understand this alarm, let's find out what a servo motor does. Like steering a car, when you turn the steering wheel, the wheel responds immediately and moves exactly where you want them to go. CNC machine also works in a similar way. Each machine axis, such as X, Y, and Z, is driven by a servo motor. These motors are responsible for moving the table and spindle accurately to the commanded position. Now imagine you are trying to push a heavy cupboard across the floor. If something blocks it, you have to apply more force. Eventually you stop because you can't move it further. A servo motor experiences the same situation. If an axis becomes overloaded, gets stuck, loses feedback from the encoder, or if there is a problem with the servo drive or electrical system, the CNC control immediately stops the machine and displays a servo alarm. This alarm is the machine's way of saying, I commanded the axis to move, but something isn't right. As an operator, your responsibility is not to repair the servo motor, instead carefully read the alarm message, note which axis is affected, check whether anything is physically obstructing the machine movement, and observe if there are any unusual sounds or vibrations. If the alarm persists, report it to the maintenance team immediately. Servo motors are the muscles of the CNC machine. If muscles can't move properly, the machine can't work accurately. Now let's become another most common thing. It is the spindle alarm. What's a spindle alarm? So spindle alarm can be of different type. Abnormal speed, it can be malfunction, it can be the rotation may be stopped, the spindle may be overloaded or overheating. What we have to do? We have to again check the alarm message and contact the maintenance. Next is the tool changer alarm or the ATC alarm. This happens when the machine cannot change the tool, automatically change the tool correctly. Why? Because maybe it was not loaded properly, or it was not home properly, or the tool was not seated properly, the magazine failed to rotate, the tool arm couldn't complete its movement, or sensor didn't confirm the tool position, etc. etc. To prevent a crash or dropping, the CNC immediately stops the cycle and displays an ATC alarm. When this alarm appears, never try to force the tool changer by hand while the machine is forward. Read the alarm message carefully, check whether the tool is stuck, confirm that magazine is aligned correctly, and look for any obvious obstructions or loose tools. Next is the low pressure alarm. What is low pressure alarm? Low air pressure alarm. Why do we need air and compressed in CNC? Compressed air in CNC? Because compressed air powers several important machine functions. Depending on the machine, it may operate ATC, spindle air, tool unclamping mechanism, pneumatic cylinders, and other safety systems. Think of compressed air as a machine's breathing system. So imagine trying to inflate a balloon with very little air. No matter how hard you try, the balloon won't expand properly. A CNC machine faces similar problem when the air pressure drops below the required level. The control detects the low pressure and immediately stops operation. This prevents incomplete tool changes, poor clamping, or unexpected machine behavior. Common reasons for this alarm include a switched off air compressor, insufficient compressor pressure, air leaks in hoses or fittings, clogged filters, or excessive air consumption elsewhere in the workshop. When the alarm appears, don't keep pressing the cycle start or reset. Instead, check the air pressure gauge on the machine. Verify that the compressor is running and supplying the required pressure. Listen for any hissing sounds that could indicate an air leak. If the pressure returns to normal, the machine can usually resume operation safely. If not, report the issue to the maintenance. Next is a lubrication alarm. Lubrication alarm means we tell that for the moving parts like guideways, ball screws, and bearings, these items move thousands of times during normal machine day. So, like a bicycle with a dry chain, CNC machine works exactly the same way. To reduce friction and wear, the machine has an automatic lubrication system. At regular intervals, it pumps small amount of lubricating oil to critically moving components. If lubrication oil level becomes too low, the pump fails, a pipe becomes blocked, or the system cannot bind the required pressure, and CNC controls generates a lubrication. The machine isn't stopping because something has already broken, it's stopping to prevent expensive damage before it even happens. When you see this alarm, first check the lubrication oil reservoir. Make sure the oil level is above the minimum mark. Look for any visible oil leaks around the machine and verify whether the lubrication pump is operating on. Next is the coolant alarm. Whenever a cutting tool removes material from a workpiece, a large amount of heat is generated. If this heat is not controlled, the cutting tool can wear out quickly and the workpiece surface quality may reduce and machining accuracy may suffer. So, the CNC machine, the coolant system, continuously sprays coolant onto the cutting tool and the workpiece. This helps reduce the heat, lubricates the cutting process, washes away the metal chips, and improves the surface finish of the machine part. If the coolant level becomes too low, the coolant pump fails, a filter becomes clogged, or the coolant level flow is interrupted. So in such cases, the CNC control may display a control alarm. When this happens, don't ignore and continue machining. Check the coolant tanks and make sure the coolant level is above the minimum. Look for any leaks, verify the pump is running, and ensure coolant is flowing properly through the nozzles. So we have covered machine errors and the safety errors. Now we are going for the programming errors. Unlike safety or machine, programming is done caused by the incorrect CNC instructions. Like you are using Google Maps and accidentally entering the wrong destination. The car isn't damaged, the road isn't blocked. The problem is simply that the instructions are incorrect. A CNC machine works in the same way. It follows every instruction written in the CNC program. If the program contains a mistake, the machine cannot decide what you mean. It only knows what you told it to do. When the control finds an invalid command, a missing value or incorrect tool or conflicting instructions, it stops the program and displays the program. So first thing is the program error. Program error means it's a general error that tells you that something in the CNC program is incorrect, but this not always means there's a problem with the machine. Like, for example, in the recipe, it says bake the cake for 30 minutes, but it never tells you what temperature to use. The instruction is incomplete, so anyone following it will be confused. A CNC machine reacts in exactly the same way. Every time a CNC program, also called a block, must contain complete and meaningful instructions. If an essential value is missing, the sequence is incorrect, or a command doesn't make sense of the current situation. The control stops and the program and the displays a program error. Next is a syntax error. Syntax error means the correct way of writing something. Syntax means correct way of writing something. It's like a spelling mistake. CNC machine is very different. You cannot guess. If at all I give a spelling mistake when I send a message, the other person can understand, but CNC can understand. CNC understands only commands that follow the correct format. Every G code, every M code, every letter, every value after that, every command must return exactly as the control expects. A small typing mistake can be enough to stop the entire program. For example, you might accidentally give type G0O instead of G00. That is, instead of using the number 0, you have entered the value as letter O. So what happens? These mistakes look minor, but to CNC control the instruction that simply doesn't make sense. When a syntax error appears, don't immediately assume the whole program is wrong. Most of the time, the problem is limited to one line. Next is the illegal G code or encode. So what happens? Every CNC controller, Fanuc, Siemens, Mitsubishi, Haas or another brand, supports a specific set of G codes and M codes. While many commands are common across different controls, some are unique to particular manufacturer or machine model. If your program contains a command that your CNC control doesn't recognize or doesn't support, it immediately stops the program and displays an illegal G code or illegal M code alarm. This usually happens when copying programs from another machine using the wrong post processor or accidentally typing an incorrect code. For example, you may use G code that exists on one control but not on another, or call a M code for a machine function that isn't available on a machine. When this alarm disappears, don't assume the machine is faulty. Instead, identify the highlighted program line, verify the G code and M code against your machine's program line, and replace with the correct. So, what should you do when the alarm actually appears? Many beginners make the same mistake. The moment they see a red alarm on screen, they panic and immediately start pressing the reset button repeatedly. That's not troubleshooting. Instead, follow a simple routine every single time. First step, stay calm. Remember, the machine is trying to communicate with you. An alarm is an information, not a reason to panic. Next step 2, read the alarm message carefully. Don't just look at the word alarm. Read the complete message and note the alarm number if it is displayed. That number is always the biggest clue. Step 3. Identify the type of alarm. Ask yourself, is the safety a machine or a programming alarm? Step 4. You should perform the basic checks. For example, is the emergency stop pressed? Is the machine door closed? Is the air pressure normal? Or is the lubrication oil sufficient? The CNC program containing obvious errors. Many errors are solved within these simple inspections. If the problem is still not clear, stop and ask for help. Now let's look at the 5 golden rules that every CNC operator should remember. These rules apply whether you are working on a Fanuc, Siemens, Mitsubishi, Haas or any other CNC machine. Rule number 1. Never panic. An alarm doesn't always mean something has broken. In many cases, it's simply the machine asking for your attention. Rule 2. Never ignore an alarm. Some operators try to continue production without understanding the warning. That can turn a small issue into a costly repair or even a safety incident. Rule 3. Read before you reset. The alarm message and the alarm number are valuable clues. If you press reset immediately, you may lose the information that helps identify the real problem. Rule number 4. Follow the machine manual. Every CNC machine has recommended troubleshooting procedures. If you are unsure, refer to the operator's manual or maintenance guide instead of guessing. Rule 5. Put safety before production. Meeting production targets is important, but no job is worth risking an injury or damaging an expensive machine. A good CNC operator isn't someone who never sees alarms. A good operator is someone who responds to alarms calmly, logically, and safely. If you develop these habits early in your career, you will save time, reduce downtime, protect the machine, and earn the trust of your supervisors and teammates. Remember this final thought: machines can be repaired, parts can be made, but safety must never be compromised. Now that we have seen the right way of handling CNC alarms, let's discuss one of the most common mistakes operators make. These mistakes are seen in our workshops every day, especially among beginners. Number 1. Pressing the reset button repeatedly. Many operators believe the alarm will disappear if they keep pressing reset, but remember, reset clears the message. It does not remove the cause of the alarm. Number 2. Ignoring warning messages. Sometimes machines give a warning before a major problem develops. Ignoring those warnings can eventually lead to machine damage or unexpected downtime. Number 3. Guessing instead of checking. Never assume you know the problem. Always read the alarm message, inspect the machine, and verify the actual cause before taking action. Number 4. Bypassing safety device. Opening interlocks, defeating door switches, or disabling safety features just to save a few minutes is extremely dangerous. These systems exist to protect both the operator and the machine. Mistake number 5. Restarting without installing. If you simply clear the alarm and press cycle start again without understanding what happened, the same problem may occur immediately or become even more serious. Always remember, every alarm has a reason. Find the reason first, then restart the machine with confidence. So as we come to the end of the seminar, let's quickly recap the most important lessons we have learned today. We started by understanding that not all CNC alarms are the same. Some are designed to protect the operator, some to protect the machine, and some others help identify the programming mistake. The first step in solving an alarm is to recognize which category it belongs to. Then we learned about some most common alarms that every CNC operator like to encounter, including emergency stop, travel, door open, etc. More importantly, we learned how to respond when an alarm appears. Don't panic. Read the alarm message carefully. Identify the cause. Perform basic tasks. If the problem cannot be solved safely, ask your supervisor or maintenance team for assistance. Every experienced CNC operator has encountered alarms. What makes them experienced is not that they avoid every alarm, but they know how to respond to calmly and correctly to each alarm. If you develop these habits from the beginning of your career, you will become a safer, more confident, and more reliable CNC professional. And always remember, a successful CNC operator doesn't just run the machine, they understand what the machine is trying to say. Anyway, now we have reached the end of today's webinar. Thank you so much for joining me and spending a valuable time learning about CNC machine alarms every operator must know. I sincerely hope this session has helped you understand not only the different types of CNC alarms, but also the correct approach to handling them safely and confidently. Remember, alarms are not something to fear. They are the machine's way of communicating with the operator, helping prevent accidents, machine damage, and costly downtime. A knowledgeable operator does not simply clear alarms. They understand the cause, take the right corrective action, and ensure the machine is safe before restarting. If today's webinar has inspired you to build a career in CNC machining and manufacturing, I'm delighted to let you know that enrollments for the batch 7 of our 45-day CNC Operator and Programmer course have now started. This is a comprehensive industry-oriented training program designed to help students, freshers, and working professionals develop the practical skills that today's manufacturing industries expect. Seats for the upcoming batches are limited and only a few seats are available. If you are interested in joining or would like to know more about the course structure, contact us by using the details displayed on the screen. I would also like to invite you to continue learning with us through our free technical webinar series conducted every Saturday. Each week we explore particular topics like CNC machining, CAD/CAM, engineering drawing, metrology, manufacturing technologies, industrial automation, and many other industry-focused subjects. If you found today's webinar helpful, please support us by subscribing to our channel, liking this video, and enabling notifications so you never miss an upcoming webinar. Once again, thank you for your time, your support, and your enthusiasm. This is Sharad Nambia, Technical Trainer, signing off. Until we meet again, keep learning, keep improving, work safely, and keep building the future of manufacturing. Thank you and have a wonderful day.